Hello again. Welcome to Swift Basics. So today we'll basically introduce the basic structures of Swift, the Swift language. So the Swift language is type safe. What does that mean to be type safe? Well, in Swift, for example, if I declare a variable name to be Alex here, later I can come and say name equal to 45. Name on line 7 is a string. Here name is a string. I can't later in my code come and put an integer inside of the name variable. So here I'll get a compiler error saying cannot assign value of type int to string. So here Swift is a strongly typed language. Strongly typed language. Which makes it type safe. As opposed to some other languages like JavaScript, where JavaScript is weakly typed versus JavaScript, which is weakly typed language. Okay, so this is where Swift is. Swift is very powerful in that fact that it's type safe. So I can accidentally go from string name to number name or integer name. Great. In Swift, we have constants and variables. This is how we store data. So I could store data, as we saw earlier, in a variable called name. I could also have a variable is Thursday set to true. So here, this is a variable. I could change it. For example, is Thursday, tomorrow is not Thursday, so that will make it false. Right? So here, this variable, I could vary it, I could change it, I could mutate it. So variable var can be changed or mutated, right, over time. Okay. As opposed to a constant. So for example, if I say let here pi equal to 3.14, somebody else wants to change pi to say it's 4.3. Can they do this? Well, in Swift, you cannot. You cannot change a let. A let is a constant. So it's a constant, cannot be changed or mutated. Okay, so we cannot do this. This is what's known as a compiler error. So this will give us a compiler error, as we saw earlier. What does a compiler error mean? Here we have red, this whole red line saying cannot find compiler in scope, right? So here, well, not compiler, sorry. This is not the error we're looking for. But we are looking for the error that says cannot assign to value pi. It's a constant. So we cannot do this, right? Error. Next, we talk about type annotation. What does that mean? Well, type annotation looks like this. I could have var year. It's a string. And the year is 2020. To type annotate or to use type annotation is to use a colon followed by the data type of your variable. In that case, we have a string, so we annotate it to the compiler or to the person reading our code to say this is a string. But in Swift, string is what's known as, here, my string 2020 is recognized by the compiler. If the variable is automatically recognized by the compiler, this is known as, so to automatically recognize the type is known as type inference. Right. So here, this is known as type inference, because if I hold down the option key and I click on year, so holding down on the option key and clicking on year reveals that var year is a string. So there's no need to type annotated because it's type inferred. So here, this is type inference. So year is inferred. It's known as type inference. On the other hand, type annotation comes in very handy. For example, if we have a character here, let's get an emoji. Everything is great. Well, my emoji didn't come up. Okay, so here we have an emoji. And if I, again, hold down option, click on char, it says it's a string. But in my case, I want to explicitly say this char here is a character. Let's just call this emoji. I want to say it's a type character. What can I do? I could use type annotation to explicitly say this is a character. So when I option click again, the compiler says it's a character. So there's cases in Swift where you need to explicitly type annotate. This is one of the use cases. So here we need to explicitly type annotate the character data type, or it will infer as string. Great. Okay, let's talk about printing. How can we print a result to the console? So in Playgrounds, which I'm currently using, I'm using Swift Playgrounds. In Swift Playgrounds, I could print to the console. How can we print to the console? Well, print is a good start. We could say print Swift Playgrounds. And I could run my code by clicking on the play button. And with some delay, hopefully not too long of a delay, we should see Swift Playgrounds in the console, which we do see here, Swift Playgrounds. Great. We could print variables. We have variables above. I could print year by using string. So a string is open quotes, close quotes, that makes a string. So here I could print the current year is. To print out a variable, I need to use a backslash, an open parens, and a close parens. This is known as string interpolation. Known as string interpolation. This here uses like a placeholder. Think about it as a placeholder. And within the parens, I'll put my variable name, in that case, year. So now if I was to run my playgrounds again, I'll see the current year is 2020. So this is how you print variables or constants to the console. Great. Comments. Funny, we've seen comments all throughout this particular playground. So this is a comment. How do you start a comment? With /, 2 forward slashes. This is a comment. What does a comment mean? Basically, a comment doesn't get compiled by the compiler. The compiler ignores the comments. So the comments are basically notes that the developer leaves in his code or her code to a developer or to the developer themselves. So this is not compiled, right? This is a comment. So here we have a single line comment. So this is a single line comment. I can continue here and write more comments. I'll get a compiler error because 2 slashes is only for a single line, one line. But if I do want multiple lines, I would create a /*, press enter, and automatically I get a closing comment. This is a multi-line comment. So now I could say this is Swift basics. I could press return. Swift is awesome. Like that. Next one. Today is Thursday. So this is a multi-line comment, and this is a single line comment. Next, we could talk about integers. Integer. An integer is a number, a whole number. This here is not an integer. This is what's known as a floating point number. Point here, floating point number. So this is an integer. So I could say number equal to 56. This is a number. To find out the maximum and the minimum of an integer type, integer is of type int. There's other types in Swift, which we'll see later. But here, if we have an int, again, the compiler infers that this is an integer. To find out what's the maximum of an integer, I could just create a constant here and say max of int and say int.max. This will give me the maximum number that an int data type could hold. On the other side of the spectrum, I could find out what the minimum size of an integer is by saying int.min. And here I could print max of int, and I could print min of int. And run. I could actually, I don't need to click on the stop button and play here. I could also play in line. So here we see the maximum value of an integer is a huge number, pretty big. And the minimum of an integer is a really small number here. Great. So let's continue on. So floating point numbers, what does that mean? What's a floating point number? Well, this is a floating point number. If we were to say, let's say taco price is $3.50. This 350 here represents a floating point number. Again, you have your whole number followed by a decimal and 50. So this is a floating point number. And what type does Swift infer this 3.5 to be? Well, if we option click on it, we see it to be type double. Double. What does double mean? Well, the difference between, we'll just say difference between double and float is a double 64-bit and a float is 32-bit. So basically, it holds double the storage. So a double holds double the storage. So native to Swift is doubles. You more likely want to use a double rather than a float. So those are the differences there. They're both floating point numbers. If you want to use a float explicitly, you would have to use type annotation like that. And now if I option click on taco price, I see it's a float. So this is type annotation. Without type annotation, the compiler infers 3.5 to be a double. We spoke about type inference earlier. We also spoke about Boolean values earlier. So for example, here, I could say let, or rather a var, developer is developer true. We're all developers here. We would also maybe say it's a constant, right? Doesn't change. Always a developer. True. Great. We won't get into control flow for now, but we could simply do if is developer print keep innovating, else we could say print come over to the developer world. We'll get into if else statements later, but for now, what does this mean? Very similar to like options we have in games or just life. So if is developer, in other words, if this is true, if is developer is true, go ahead and print keep innovating to the console. Otherwise, if it's false, go ahead and print come over to the developer world. So here we clearly see it's true, so it should go ahead and print line 65. So let's go ahead and run our code. Indeed, we see keep innovating, which should not be, oh yes, it is, I'm sorry. So here we are. So keep innovating, because I'm a developer, it's gonna come to line 65. Again, this is true. If this was false, for example, if we change this to false and we run the code again, we'll clearly see come over to the developer world because it's false. Great, so this is what Boolean values enable us to do. Have if statements, which we'll see later, but for now, this is an introduction to Boolean values. We have true or false. Great. Next, we have tuples. What is a tuple? Well, in my case, I could create a tuple here, call it person. And person has, this is the syntax for a tuple, open parents, close parents. Person has an age, say they're 21, and the person has an occupation, they're an iOS developer. Like that. So this is a tuple data type. If I option click on it, I see it's a tuple data type where the first type is an integer, 21 is a number, it's an integer, and the second type is a string, iOS developer is a string. To access this tuple, I could simply, well, we could just print out, print person, run the code. And here we have 21 iOS developer. We could be more explicit and we could access the person's age by saying print person.0 or 1. 0 represents 21, the first value. 1 represents the second value, 0. So if we were to print that out, it's going to print out 21, which it does. But for better brevity, to make this easier for you to read, as well as your colleague reading your code, you might want to do labels. You could actually put labels here. So I could say age, colon, and for the occupation, I could just write out the word occupation here with a colon as well. And now instead of like using .0 to access age, I could say age. Like if I do dot, I have access to age and occupation. So age is more explicit. I know exactly what I'm accessing. So now I have 21. Great. Next, we'll go into optionals. Optionals is a big part of Swift. Optionals basically says there could be a value or not have a value. So an object or variable, let's just say a variable, may have a value or a value may not exist. So optionals allow us to do that. Let's take a look at it. So here we'll create a number. We have number already. We'll create, let's create input, for example, input from the user. The user inputs some character, some string. The string the user created was 45, for example. So we got the input from an app that the user entered. They use the keyboard, they enter the number, it's 45 as a string. Now we want to say, let's go ahead and convert the input to an int, to an integer, because we want to deal with numbers. So here we want to convert it. To convert it, we use the integer initializer. So this is the integer initializer, int, open parents, close parents. In that initializer, we'll put an input. So using the int initializer to create an integer from a string. Okay, input, this is a string. So let's see what types we have now. If I option click on input, it's a string here. If I option click on convert input, it's an int question mark. We haven't seen that data type. Int question mark. Int question mark is an optional. The way we say this is int optional, or int question mark is an optional. It's an optional int, right? Again, optionals are a variable or constant that may have a value. It may have a value, or a value may not exist. In other words, the value, if the value doesn't exist in Swift, this is known as nil. So if there's no value, it's nil. There's nothing. So one of those two things could happen from this convert input. Either we have a value, which is valid, or we don't have a valid value. In that case, it's going to be nil. So how can we use that value, right? How can we use that value? We could use that value with optional binding. Optional binding unwraps an optional value and stores in a variable or constant, right? Because here we have this value, it's optional int. We want to be able to use it. How can we use it as an int? I do not want to use it as an int question mark. I want to use it as an int. How can I do that? Optional binding. This is what the syntax looks like. I will say if let, right? This is what the syntax looks like. If there is a value, create a constant, call it number, equal. So on the left side, this is where if there's a value that exists, that value will get placed into number. The value we want to unwrap goes to the right side of the equal sign. So here we'll have convert input, open curly bracket, close curly bracket. So now let's see what the compiler does for us. This here is an optional value, int question mark. If we option click on number, number now is an int. This is exactly what we want. We want to take int question mark and convert it to an int. But if for some reason that 45 is not valid, right? 45 won't be valid if, for example, 45 is for, like if the user entered 45 like this. This is not going to be valid. This is not a number. This is not an integer. So what's going to happen if it's not valid? If it's not valid, it will come to the else statement here. So if it's valid, it will come in here. So valid number. If it's not a valid number, actually let's call this valid number. It's a better name. If it's not valid, it will come inside the else statement here. Value is not valid, does not exist, is nil. Okay. If statement, we come inside of the if statement, block. This is the block, open curly, close curly. This is known as a block, right? So this here is a block of code, right? Open curly, close curly is a block of code. The if statement, it's block of code, its scope, right? Block of code, its scope is on line 83. So here, I will only get in here if this number is valid. So here we'll print valid number. We'll use string interpolation and we'll say valid number. If it's not valid, we will print number is not valid, is not a valid integer. Okay, let us see what that looks like. Let me make my console a bit bigger and let's run our code. So here we have number is not valid because 45 is not a valid number. If I was to change this to 34, for example, and run the code again, this time I will see valid number 34. So now I could do anything else I want with this valid number. So there's optional binding, and there's also, in closing, we could unwrap an optional using nil coalescing as well. Right, so what does nil coalescing look like? We've seen optional binding. Again, optional binding, this is the syntax. If let valid number, in that case, optional binding, we would have to say let valid number equal to convert input. This is an optional. We need to unwrap the optional. Unwrap, think of a box, open the box to see if there's a gift in there or if there's no gift in there, right? So in that case, we want to unwrap what convert input is. But this person is so kind. If there's nothing in there, in that case with nil coalescing, if nothing exists in the box, or assuming there's no gift in the box, they happen to just leave us something by default. If there was no gift, they happen to give us a default gift. So what does that default gift look like? We use two question marks. This is the nil coalescing. This is nil coalescing, the two question marks, and space, and you give it a default number. In our case, for our input, we could say -1. Depending on your use case, you could say -1, you could say 0. It depends on what default number you want. In our case, let's just stay with 0 for now. That could be a good case here. What are we trying to do? The person adds some input. Okay, so 0 is probably okay. They added some input. The input wasn't valid. We default to 0. So this is a good default value. So default of 0, right? Can be any number in your business case or application, depending on. Great. So now what does that look like? I will print valid number. If this is a valid number, it will have the valid number, whatever number it is. If it's not a valid number, it's going to default to 0 and we'll get 0 here. So we still have our valid number up here, or rather we have our convert input up here. Let's just do valid here so we're not confusing us with the reading. So valid, and I run the code. And here it's valid because we got 34. We got 34 with optional binding, and we also got 34 with nil coalescing. So let's reverse this. If we have not a valid number, like 1, for example, and we run the code again, we'll get 0. This is our default number. And in our optional binding, we'll get number is not a valid integer. So depending on your use case, you might want to use nil coalescing, or you might want to use optional binding. But as you create more applications with Swift and iOS, you'll see what's the best use case for you. Again, thank you for watching.